Assalamualaikum warahmatullahi wabarakatuh. So this is a video for presentation about the PPL from group 8. So this is our members group 8. My name is Afif Najmi bin Haizul, CE 200 106. So my friends Nik Muhammad Afif bin Nik Baharudin, Muhammad Azad Haziq bin Jasmani, and Nur Hazikah binti Afandi. So before we start, for information for this presentation, this time we divide into two members for the PBL presentation, and two members for the assignment presentation. So we go through about the introduction for PBL. The purpose of motor position controller is to take a signal representing the required angle and to drive a motor at that position. So secondly, microcontroller based position consists an electronic component, and microcontroller can provide easy control of a DC motor. Then DC motor consists of stator, armature, rotor, and commutator with brusher. And then advantage can develop constant turkey over a wide speed application. And then in this assignment, we simulate the plan of DC motor by applying Newton's second law with the Allenberg principle by implementing PI, PD, and PID controller on the MATLAB software. And lastly, purpose to compare which is the best controller work in the system. So we go through about the methodology. Firstly, sketch a block diagram and copy the plan of DC motor. Then make the block diagram utilizing by MATLAB software to produce the output. Secondly, use MATLAB software to apply the usage of the regulator. It produces the measure of the output voltage signal. This is a figure about the position of PID in control system. So we go through the result and analysis from my friends Nik Muhammad Afif.
Assalamualaikum, my name is Nik Muhammad Afif bin Baharudin. My matrix number is CE 200021. I will present the simulation for PBL. This is a PID controller. We use P controller. This is step. We change the final value to 0.008. This is subsystem. This is the block diagram for subsystem. Before we run the block diagram, we must put the code first. We must run the code first. This is code for the subsystem, which we get it from the instruction given. First, we must run the code. Then we go to this diagram and we run the simulation. Then after that, we click VM. This is output for VM graph. Then this is output for the S1. This is output of S of the manual. Then we go to P controller and click tune. This is graph we get from the auto tune. We will change the time to 5 seconds. Then we click update block. This is for manual tune, and this is the parameter. After that, this is PID controller for PI controller. The step we change the fan value to 0.008. Then we run to get the graph for VM. Okay, this is output for the VM graph that we get from the block diagram simulation. This is S1 output, and this is S graph for manual. And then we go to tune okay, this is the output that we got from auto tune. Then we change the time to 5 seconds and we click the update block. Okay, this is the output that we get, and this is the parameter for this PI controller. Then we change the controller to PD controller, and the step we change the final value we change to 0.008, and we run the program. Okay, this is the output for VM. This is the output we get for the S1, and this is the graph for S for manual. Then we go to tune the PD controller. Okay, this is graph we get after we auto tune. Then we change the time to 5 seconds and we update the block. Okay, this is the output for the graph after we change it to 5 seconds, and this is the parameter for this PD controller. Lastly, this is for the PID controller. We set the step, the final value to 0.008. Then we run the simulation. Okay. Then we get the output graph for the VM. This is the output graph for the VM. Then this is the S1, and this is the output graph for the S1, and this is S for the manual. This is the graph. Then we go to tune the PID controller. this is we get for the output for the auto tune. Then we change it to the 5 second and we click the update block. Okay, this is the output graph for the manual tune, and this is the parameter for the PID controller. Okay, that's all for the simulation. Thank you.
So thank you for Nik Muhammad Afiq for the present about the result and analysis. So next we go through about the conclusion and recommendation. To conclude, PIPD and PID controller was inserted into a system of DC motor to see which one of the system creates a linearizer system. The simulation was done for the system with and without controller. The response characteristic of DC motor improve with PID control. The optimal value for controller parameters are obtained by the mathematical model of DC motor that include applying Newton's second motion of law together with the D'Alembert principle. The equation of motion of DC motor, the simulation result proven that PID controller compare other controllers which designed by changing controller parameter value is an easy tuning and more effective way to enhance stability of time domain performance of the DC motor system. It is recommended that PID controller is to be used in closed loop system for a better linearizer system and easy tuning performance in creating object. This is because PID controller vastly used to control 2 or higher order planks, which result in fast transient response and zero steady state error as desired for closed loop system. So thank you very much. That's all for me.